Welcome to this presentation on Tekla and the Qnect connection design system, customer-driven optimization. Qnect is an innovative and new way to do connection design directly from your Tekla Structures model. Quite simply set up your preferences, pass the data from the Tekla model to the Qnect cloud where the connections are designed, optimized and then passed back to the Tekla Structures model along with full calculations. Let's take a look at that in more detail. Here we have a typical Tekla Structures model, built with member sizes, orientations, positions, grids, a typical structural building. We can also look at more detail by applying the end loads to the end of each of those elements. These can be applied manually, or they could of course come from analysis and design software, such as Tekla Structural Designer. On this model I've also created the drawings, and you can see here we take a quick look through the drawings. We can see we've got elevations, plans and three-dimensional views. These of course will update to the Qnect design system. Typically, to apply connections we have a library of components within Tekla, and we quite simply select the connection we want and drag and drop it into the model or by area. The connection then is set up to suit the engineers or detailers or fabricators standards by simply clicking on it and changing the parameters. Typical method of applying connections within Tekla. Using Qnect, I can connect this whole structure in one go by simply going to the Qnect website, creating an account and signing in. Once signed in, I can then download the Qnect applications that run within Tekla, the extensions, so we'll download those. You can then see once these are downloaded, we can install them into Tekla Structures, and you can see then on my Steel tab we have then the Qnect tools ready for me to use. So now I'll set up my first project within Qnect. I have a range of different projects which might be for different fabricators or different detailers. I'm going to set a project up here which is called Tekla Demo. Let's click on this one. Within here I can edit this to my own personal or my fabricator's preferences. So I'm going to tell it what Tekla version I'm using, the codes I wish to work to, and a couple of interesting options here: preference optimization and bolt optimization, which we're going to take a look at in detail later. First of all, I'll just go through and set up the basic information, the design codes I'm working to, what kind of connections I prefer to use and the order of preference that you can choose them from. And again, different clearances, setbacks, are the bolts staggered, and general preferences that you use when detailing or fabricating a contract. Once I've set up those preferences, I can then utilize them within Tekla when I pass my data to the Qnect connection design software. So if we go back to the Tekla model, we can then select the area which to do the connection design on, use the Qnect tool, option number 1, sign into the service, and then export that data out to the project we've just set up, giving it a name. That project is now passed to the Qnect cloud where connection design is considered. Once the connection design is complete, we will then get an email notification informing us of this and telling us we can import the data back into Tekla. To import the data back into Tekla, we'll use the Qnect tool again, and we'll select option number 2, which is to import the data back into Tekla. Again, sign into the service, select the project and select the session that we just determined, and you'll see then the connection design for that particular model is passed back into Tekla, and we can see the connections are there full and complete to the preferences I set up within the Qnect dashboard. So bolt spacings, staggered, the order of preference it would use connections in. You can see there fully designed, connection designed and complete directly from the Qnect cloud. I can click on these connections to see the connection design itself or the format. So let's just double click on this connection here and we can see the connection design for the whole project and some sample job calculations as well. all fully done and complete by simply passing that information out to the Qnect cloud. Again, let's just click another connection and again see the results. We can always then inspect every connection done by Qnect by running the option number 3, the Qnect inspect, and then we can see all the connections designed in a matrix format, so beam to beam, beam to HSS, all categorized for us, and as we click on each connection it will walk through the Tekla model showing us each connection so we can visually check we're happy with the connection done by Qnect, which of course we could alter if required. If we now take a look at our drawings again that we saw earlier and zoom in, we can then see the connection, the Qnect connection is highlighted on the Tekla Structures drawing, so we have a reference to each connection that's been done for us and a reference to the calculation. We also can see any connections that have not been designed for some reason, if it's an invalid part or it's not allowed, and we can see those are highlighted in red for us. And of course the 3D drawing itself will update to show the relevant Qnect connections. We can also indicate any kind of information we want on that 3D drawing, such as member sizes and the connection types used. Now, revisions will always happen on projects, and while these connections have already been designed, if we make changes, the Qnect connection design software will take these into consideration. So for example, if we change the size of this piece here, in the background the Qnect listener is looking for changes and it will find and indicate to us if any revisions are needed. So if we rerun that connection again we get the email telling us that connection has been successfully redesigned, and then again we can log into the service and bring that revision into the Tekla model. In this case it's revision 1. So changing the size of that member, the Qnect has listened and looked for any changes, automatically picked that up and then redone the connection design for us, only on the relevant elements that need redesigning or the relevant end conditions. And again, this is full and complete with the full calculations to verify that connection. As we take a quick walk through there, you can see all the calculations. And if we make another revision, we can see again the connection will be redesigned as the Qnect listens for changes in the model, and again it will re-engineer those connections and connection design, again with the fully relevant calculations to back it up. Now let's take a look at some optimization options within Qnect. First of all, bolt optimization. Here the connections are full with bolts, but what we want to do is optimize those down the number required as per the connection design. So we'll say let's turn on bolt optimization and then rerun Qnect again. You can see then the number of bolts is minimized, but the connection design is still valid. So there, and all the connections all the way through that structure are optimized to use the standard spacing, which uses less bolts. However, the connection design verification is still there and calculation to back that up. So again, we had full bolts without optimization. Let's take a spin around there so you can see the number of volts is much more than with the optimization. So as we now see with optimization, as we turn that back on, there we are. And within Qnect as well, we can also see the cost implications of that optimization on the project. So as we walk through the calculation, we also get the cost figures which tell us how much we saved by using bolt optimization on that project, and the figures are shown there in green. Some fantastic savings to be made. So let's just take a look through those costs and cost savings, as you can see there, broken down into bolts, material costs, weld costs and so forth, based on bolt optimization. Now let's take a look at preference optimization. So let's go back to the Qnect dashboard, go back to my project, edit the project, and again one of the options in here now is for preference optimization. We've already turned on bolt optimization, so let's now turn on the preference optimization. This means it will look at my preferences, run through different scenarios and do the connections based on the best and most cost efficient way to manufacture and fabricate the connections, giving me even more cost savings. So we now run that project through again, and we can now see the connections are done using the preference optimization. Again, my email confirmation it's been done. Import the new with preference optimization, and we can see now the model is complete, still connected, still designed to our preferences, but the preferences are being looked through in different scenarios to give us the most cost-effective way to fabricate and manufacture that structure. And again, we can then go back to the Qnect dashboard and we can take a look at the reports, which gives us the full savings using the preference optimization. So let's take a look at that report. And here we can see then the savings that can be made using preference optimization as well as the bolt preference optimization. Qnect looks through several scenarios to find the best and most cost-effective way to fabricate and manufacture those connections based on the connection design. Here you can see some of the savings, including bolts, erector costs, number of bolts, total costs, bolt optimization, preference optimization. So if we now take a look at the model, we can see it's fully connected using both bolt optimization and my preference optimization. So the structure is now full and complete with all verifications ready to go for fabrication. Thank you for taking your time to view this quick presentation of Qnect and Tekla, and hopefully we'll see you soon at one of our next presentations. Thank you.